Hello, 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 hello. Basis and bases. Very important topic. Let's jump in with this B here. But what do we notice about this B? Well, we notice that span of B is all of R2. Since, well, if I have something chosen at random in R2, I can decompose it like so. And that's obviously in the span of B. Okay, so anything in R2 is in the span of B. And obviously, everything in span B is in R2. So we get this equation. So we say in, for now, unmathematical and vague language, but I think it'll help motivate. We say that B is enough to cover R2, okay, in the sense of the span B equaling R2. Okay, but what if I took something away from B? So what if I removed something from B? Would I still cover R2? No. So you can look at it two ways. You know, if I look at just this span, okay, that's evidently not R2. The span of a single non-zero vector in R2 is a line. It's not the whole thing. And if I were to remove 1, 0, I would get this span, which is also not R2. Okay, so I can't remove anything from B and still cover R2. Now, what if I were to add something to B? So I will ask you to consider C, which is B plus one more vector, say 2, 3. Now, you know, the span of C is still equal to R2. But notice that this vector here, 2, 3, is not doing anything. It's not really carrying any weight here. Okay, because R2 is the span of the smaller set B. So what do we say? 2, 3 isn't doing anything. In other words, C, I would say C has extra crap in it. Okay, very mathematical language. We're going to make this more precise in a second. What are we going to say? So more precisely, C is linearly dependent. And B is linearly independent. Okay, these two facts here, if you don't believe me, then you should check these things yourself. So what have we come to? Okay, so B is in some sense perfect. So B is perfect. We'll say 1. It covers R2. Oops. And 2. Before I say that, 1. It covers R2. You know, we'd say it's enough. 2. It's linearly independent. There's no extra crap. So B is this perfect set. Perfect, perfect, perfect. And that's what we're going to call a basis. So we say B is a basis of R2. So it's linearly independent. That's one condition to be a basis. And the other one is, well, I'll write down a formal definition shortly, but it's covering R2. So what I mean here is that span of B equals R2. So being enough is the span equals R2, and no extra crap means linearly independent.